All right, let's talk about a total production nightmare. We're going to break down how a single, perfectly normal-looking line of code can take down a massive high-traffic service.
So let's set the scene. Imagine you're running a big-time payment API. It's the middle of the afternoon, peak traffic, and you've got something like 10,000 users hitting your service at once. For months, this thing has been an absolute rock, but not today. All of a sudden, your pager just explodes. The latency, which usually sits under a comfy 200 milliseconds, has shot up to 8,000 milliseconds. That's a full 8 seconds, and it's not stopping. Requests are timing out. Real money is being lost.
And here's the part that gives engineers cold sweats. You pull up your dashboards and everything's green. The infrastructure looks totally fine. But you know, from your user's perspective, you are completely and totally down.
So let's get into it. First, we're going to examine the crime scene. And this is a weird one, because it looks like all the usual suspects. Your CPU, your memory, your database, they all have a rock-solid alibi.
And this is what's so maddening, right? Your CPU is a little high, but it's not pegged at 100%. Memory is totally stable. The database is zippy. Your health checks are even passing. The load balancer thinks every instance is perfectly healthy. And yet, thousands of your users are just staring at a loading spinner.
So, after what feels like an eternity of frantic digging through logs, the team finally pinpoints the problem. And it traces back to a single, tiny, innocent-looking change that got pushed to production just a few hours ago.
You know, this wasn't some crazy, complex bug. It was way simpler and way more fundamental than that. The entire outage boiled down to a basic misunderstanding of how Node.js actually works, all hidden in just one line of code.
And there it is, the murder weapon. I mean, look at this. It's just a standard JSON.parse. How many times have you or I written this exact line? It passed all the tests, it sailed through code review. So what on earth could be the problem?
Well, the problem was scale. See, a single big customer started sending a perfectly valid but huge 2.5 megabyte chunk of JSON. Now, for a tiny payload, this function takes like a millisecond, no big deal. But for this monster payload, it suddenly took 200 milliseconds of pure, uninterrupted CPU grinding time to finish.
Okay, so you might be thinking, 200 milliseconds, is that really so bad? And in the world of Node.js, the answer is yes. It's an absolute catastrophe. And to see why, we gotta pop the hood and look at the engine of Node, the event loop.
You see, the event loop is Node's superpower. It's what lets a single thread juggle thousands of connections at the same time. But, like every superhero, it has a kryptonite. If that main JavaScript thread gets busy with some heavy lifting, the entire event loop just stops. It completely freezes.
And this distinction right here, this is the whole game. When you're waiting on a database, that's asynchronous. The event loop says, cool, let me know when you're done, and goes off to handle other requests. But when it's running synchronous code, like our JSON.parse, it's blocking. It's like the whole system holds its breath, and absolutely nothing else can happen until that one function is finished. Okay, let's zoom right in. We're gonna watch this disaster unfold in slow motion and see just how that one blocking request creates a traffic jam for everyone else.
So here's what happens. At time 0, our big request hits and starts parsing. The event loop freezes. 4 milliseconds later, another request comes in. It has to wait. At 16 milliseconds, 2 more arrive. They're stuck too. By the time our 200 millisecond parse finally finishes, a whole queue of other requests has piled up behind it, all of them delayed. This is a classic traffic jam called head-of-line blocking.
And here's where a small problem becomes a complete system meltdown, because that 200 millisecond pause doesn't just create a little delay. In a live production system, it triggers a devastating chain reaction. It's a truly vicious cycle. That initial queue starts to grow. This causes requests to time out. The load balancer sees the timeouts and thinks the service is flaky, so it helpfully retries the requests, making the traffic jam even worse. Then the mobile and web clients start retrying, and all these backed up requests start chewing up memory, which makes the garbage collector run more often. And guess what? That's also a blocking operation. Every single step just makes the next one worse. So the big question is, how do you keep this from ever happening to you? Well, it really comes down to a shift in your thinking. You have to stop just asking, is my code correct? And start asking a new question. What is my code's blocking risk? So, what's in the toolkit? Well, instead of a synchronous parser, you use a streaming one for big payloads. Any serious number crunching, you move that over to a worker thread so it doesn't block the main event loop. You start making, is this blocking, a mandatory question in every code review.
But really, if I can leave you with just one thing, it's this. Start monitoring your event loop lag. It's the one metric that would have screamed that something was wrong long before a single user was impacted.
So think about it. What's hiding in your own code base? Because in a high concurrency world like Node.js, a single line of synchronous code isn't just a performance tweak, it's a system-wide outage just waiting for the right request to set it off.